The last topic in reaction stoichiometry calculations is percent yield. And that basically describes how complete your reaction is. So let's take making popcorn as an example. If you start with 100 kernels and try to pop them, and at the end, after you do your reaction in the microwave, you only find 82 that actually popped and 18 that remained unpopped. So the theoretical yield for popping 100 kernels is basically if all of them popped out when the number of popped kernels is 100. But what actually popped in this example is 82. The percentage of the kernels that popped is going to be the ratio between what actually popped to what should have popped if the reaction is complete times 100. 82% completion of the reaction. This here is called the percent yield. It's always a percent that is less than 100% because a reaction is never 100% complete due to the impurities. For example, if you start with 100 kernels, but they're not all kernels. You have one stone in them. So the maximum amount that you will get in this case is going to be 99 even if the reaction is complete. Also, most of the chemical reactions will have byproducts, products that are undesired. And most of the chemical reactions are going to be incomplete. Some of the reactants will remain unreacted. Calculate the percent yield by comparing the actual yield to the theoretical yield. So the actual yield is actually the actual number of grams that form in the reaction, and the theoretical yield is the calculated grams assuming 100% efficient reaction. So a typical way to produce titanium, which is a very industrial important metal, is by reducing titanium tetrachloride using magnesium at high temperature. So if we start with this mass of titanium tetrachloride and react it with this mass of magnesium, how much titanium are we expecting to get? This is going to be basically calculating the theoretical yield of titanium in this case. And the second question is, what would be the percent yield if what you actually obtain is this much here? Calculating the theoretical yield is going to require determining which one of the reactants is the limiting reagent. One easy way to avoid the confusion with the different molar ratio in the equation is going all the way up to the grams of the products that will form. So we'll take grams of reactant A, which is titanium tetrachloride, convert them to moles titanium tetrachloride, and then moles titanium that will form. In this case, if you consume all the amount of titanium tetrachloride that you have, and repeat the same thing using the other reaction. So you start with grams of magnesium, convert them to moles of magnesium, and then moles of titanium that will form if all the magnesium is consumed. Compare these two number of moles of the product, and the smallest number is going to correspond to the limiting reagent. It's going to be 3.54 times 10 to the power 7 grams of titanium tetrachloride. We need to convert them to moles using the molar mass of titanium tetrachloride, which is 189.7 grams titanium tetrachloride per 1 mole. Now we have the moles of titanium tetrachloride. We need to convert them to moles of titanium that would form using the mole to mole ratio, which is 1 to 1. 1 mole of titanium tetrachloride would form 1 mole of titanium. So the number of moles of titanium that would form in this case would have been 1.87 times 10 to the power 5 moles of titanium. Repeat the same thing using the amount of magnesium. So we start with 1.13 times 10 to the power 7 grams of magnesium. Convert them to moles magnesium using the atomic weight of magnesium, which is 24.31 grams per 1 mole magnesium. Then find out the moles of titanium that would form by converting moles magnesium, 2 moles titanium. That ratio can be found from the equation here. It's 2 moles of magnesium forming 1 mole of titanium. So it would have formed 2.32 times 10 to the power 5 moles of titanium. Clearly, the number of moles of titanium that would form when all of titanium tetrachloride is consumed is much smaller than if all of the magnesium is consumed, which means titanium tetrachloride is the limiting reagent. So the maximum number of moles of titanium that would form in this case is this. So we can convert it to grams to get the theoretical yield in grams of titanium. It's going to be 1.87 times 10 to the power 5 moles titanium. Converted to grams, 1 mole of titanium weighs 47.88 grams, which is going to give us 8.95 times 10 to the power 6 grams of titanium. This here is the theoretical yield of titanium that would have formed if 100% completion of the reaction took place. But what we actually obtained with that much here. So the percent yield is going to be the ratio between these two. So percent yield of that reaction is going to be the actual yield, 7.91 times 10 to the power 6 grams of titanium, to the theoretical yield, which is 8.95 times 10 to the power 6 grams of titanium, times 100, which is going to be 88.4%.